Assalamualaikum and salam sejahtera class. Okay, for today's video, we are going to learn a new chapter, which is chapter form 5, chapter 1, which is circular measures. So let's look at our first subtopic, which is subtopic 1.1 radian. So let's look at our first subtopic. So the diagram on the right shows two sectors marked on a dartboard with radian 10 cm and 20 cm and their respective arc length of 10 cm and 20 cm. So since each arc length is the same length as its radius, so the angle subtended at the center of the circle is defined as 1 radian. So this one. Okay, since the radius, this one is equal to the length of arc, which is 20, and radius also 20. So we know that the angle subtended by an arc, which one? The angle subtended by the circle is defined as 1 radian. Before this, you learn angle was in unit degree, right? But in this chapter, you are going to learn the unit of radian to represent the angle. Okay, that is, the size of angle subtended by both arc at the center of the circle should be the same. Okay, what can you say about the measurements of the angle of 1 radian? So remember just now, 1 radian, this one we consider as 1 radian if the radius is equal to the length of arc. Okay, let's look at the next one. Next, okay, now let's we go through for discovery activity 1. So let's look at this one. Okay, this is the discovery activity. So let's look at the instruction given here. Okay, for the instruction, this one, the aim of this activity is to explain the definitions of 1 radian and then relate angle measured in radian to angles in degree. Okay, the first thing, this one is the QR code, and then the second one, we need to follow the instruction given here. So drag slider A such that the length of the arc S, okay, remember the length of the arc we represent as the variable S, is the same length as the radius of the circle. So let's drag the slider A so that the length of arc, which is S, is the same as the length of the radius. Okay, let's look at this one. Okay, this one is the slider A, and this one is the radius. Okay, this one is the angle, and this one is the S, which is the length of arc. Okay, now we need to drag the value of A so that the radius and the arc, which is S, is equal. So for example, like this one, we fix it into radius is equal to 2. Let's fix the value of the radius, which is R is equal to 2. Okay, wait. Alright, this one R is equal to 2 already. So for the length of arc, also we need to equal to 2 also. So we need to drag the slider A so that the length of arc will equal to the value of the radius. So let's okay. You look at this one, we need to make the length of arc equal to 2 by drag the value of A. Okay, alright, okay. Look at this one. The radius is 2 and then the length of arc is also 2. Means that radius and length of arc is equal. So what happened to the angle? This one angle was in unit radian and not in unit degree. So what happened? Look at the angle. So the angle is equal to 1. Okay, so it means that 1 radian. So let's look at this one. Okay, so we know that in general for a circle with center O and radius R unit, so if the length of arc AB, this one the value of radius is represent as R. So length of arc AB also R. So if the value of radius and the length of arc is equal, then our angle, which is in radian, is equal to 1 radian. Okay, so let's look at what happened when if the length of arc AB is equal to 2R, 2 times radius. Okay, 2 times radius. So what happened? Let's look at our this one. Okay, this one is the radius is equal to 2. And then what happened when if the length of arc AB is equal to 2r, means that 2 times radius. So our radius is 2 and 2 unit. So our length of arc is 2 times 2. 2 times 2 is equal to 4. So we need to drag the value of A so that our length of arc will equal to 4. Okay, we need to drag until you got 4 for the length of arc. So look at this one. Okay, this one. If the length of arc is 2r, and then what happened to the radian, which is the angle? So the angle is equal to 2 radian. Okay, 2 radian. Let's look at this one. Look at this one. This is equal, right? So 2 times of if the length of arc AB is equal to 2 times of radius, then our angle, which is in the unit of radian, it will equal to 2 radian. Okay, so let's look at the third one. If the length of arc AB is 3 times the radius, so 3 times the radius, 3 times the radius, we still fix the value of radius, which is 2, and then the length of arc is 4. But this one, the third one, they said that if the arc length AB is equal to 3 times radius, so 3 times radius means 3 times 2, 6. So we need to make this length of arc into 6, and then look at what happened to the angle. Okay, you need to drag the value of A. Okay, look at this one. Okay, length of arc is 6, and then look at the angle, which is in the unit of radian. So the angle is equal to 3 radian. So we know that this one is 3 radian. We got 3 radians. So what happened if okay class, let's look at the fourth one, which is we know that this one, if the arc length AB is equal to pi r. So you know that, okay, let's recall back what I just show you just now, which is if the length of arc AB is equal to r, so the angle, which is in the forms of unit radian, is equal to 1 radian. And if the arc length AB is equal to 2r, then the radian will become and the angle will equal to 2 radian. If the arc length AB is equal to 3r, and then the angle is equal to 3 radian. So what happened if the arc length AB is equal to pi r? So we know that based on the first, second, and third, we know that the angle is equal to pi radian. Okay, this one equals equal to pi radian. So let's look at the fifth one with this one. So if the arc length AB is equal to 2 pi r, then we know that the angle is equal to 2 pi radian. Okay, this is how you get it. Okay, now we want to relate the unit of radian and the unit of degree. Okay, so but before that, let's look at this one. Note that when the arc length AB is 2 pi r, so it means that OA has made a complete rotation, or OA has rotated through 360 degree. Okay, okay, remember this one. Pi is equal to 180 degree, but if 2 pi, so we got 360 degree complete rotation. Okay, I hope you can still remember this one. This is the basic one when you learn maths. Okay, let's look at the okay. Okay, class. Let's look at this one. 2 pi radian. 2 pi. This one. Okay, 2 pi radian. Okay, we know that pi is equal to 180 degree, right? Pi is equal to 180 degree. So if 2 pi radian, pi this one, before this, you just know that the value of, pi only, which is equal to what? 3.142. Okay, this one actually, okay, in this chapter, you will know a new knowledge, which is pi it is actually in unit radian. Okay, remember that one. So it means, okay, for this one, pi is equal to 180, we know. And then When pi is equal to pi is radian is equal to 180. So okay, this one you already know, which is pi. The value is equal to 3.142. So for 1 radian, we want to know the relation between a radian and degree, isn't it? So based on this one, this is the basic one. Okay, okay. So from this one, okay, pi radian is equal to 180. So if pi radian is equal to, sorry guys, wait. Okay, you know that this one, pi radian is equal to 180 degree. And then what is the value of degree when one radian? So 1 radian is equal to 180 degree over pi. Okay, this one you bring to the right. Then you will got this one lah. So this is from 1 radian. 1 radian is equal to 180 degree over pi. Okay, this one, if you want to convert from radian to pi, to degree. This one, this is the formula. This one just ignore. You just need to look at this one. 1 radian is equal to 180 degree over pi. So if you want to convert from radian to degree, so you need to use this one. Okay, and then this one is for, in order for you to convert from degree, okay, from degree to radian. So from degree to radian, it's still basic, this one. Okay, pi radian is equal to 180. So we want 1 degree. So 1 degree is equal to pi over 180. That's it. Okay, this one. This is where this one come from. Okay. So 1 degree equal to pi over 180 degree. So this is very important one. Okay, this is the basic knowledge that you need to know. Pi radian is equal to 180. So from this one, you are going to get this one and this one, which is, in order for you to convert from radian to degree, so you need to use this formula, which is 1 radian is equal to 180 degree over pi. If you want to convert from degree to radian, then you need to use pi over 180 degree. Okay, remember, this is a very important one. Okay, class, let's look at example 1. Okay, for example 1, the question asks you to convert each of the following angles into degree. So you need to convert this angle into degree. Okay, this is the question given to you. So this is unit of radian. So you need to convert to degree. Remember this one? Okay, this one, if you want to convert from radian to degree, so you need to use this formula. Okay, so look at this one. 2 over 5 pi radian. So 2 over 5 pi. So 2 over 5 pi radian. So 2 over is equal to 2 over 5 pi times with 1 radian is equal to what? This one. 1 radian is equal to 180 degree over pi. So you need to substitute lah the radian into degree here. Okay. And then this one, you know that the theta is this one. You can eliminate this one pi and this one pi. We eliminate this pi by cross this one and this one. So 2 over 5 times 180 degree. This one you got, and the final answer will be 72 degree. Okay, this is the formula in order for you to convert from radian to degree. Okay, let's look at B 2.25 radian. Okay, 2.25 radian is equal to 2.25. You just write down back and then multiply with, okay, this one, 180 degree over pi. Then you will get your answer will be 128 degree 54 second. Okay, this one. It is very easy actually. You just need to remember this one. If the question asks you to convert from radian to degree, then you need to use this formula. And then if the question asks you to convert from degree to radian, so this is the formula that you need to use, which is pi over 180 degree. Okay, let's look at the next one. Example 2. Okay, for example, to convert 40 degree and 150 degree into radian in terms of pi. Okay, in terms of pi. So let's look at it. First, the first thing that you need to do is 40 degree first. Convert 40 degree into radian in terms of pi. So 40 degree is equal to 40 degree multiply with, okay, remember this one? You need to use the second formula here. From degree to radian. So you need to multiply with pi over 180 degree. So that's why this is how it comes from. Okay, 40 degree multiply with pi over 180 degree. So your answer, you cannot don't substitute pi into 3.142 because the question asks you to convert into radian in terms of pi. So just let it be the unknown, the pi. You don't have to substitute the pi into this value. Okay, 40 degree multiply with pi over 180 degree. So you will get your answer will be 2 over 9 pi radian. Okay, this is the first one. And then 150 degree. So 150 degree is equal to 150 degree multiply with this one. Okay, 1 degree is equal to pi over 180 degree. So this one multiply with pi over 180 degree. Then you will get this one. Okay, and then look at B. Convert 110 degree 30 minutes and 320 degree into radian. Okay, let's look at this one. B. Okay, 180 degree. 180. This one, the basic knowledge lah. This one, it's just stated to you. Just ignore. Okay, 110 degree, 30 minutes. Okay, equal to. Okay, this one. Look at this one. 110 degree 30 minutes multiply with pi over 180 degree, and then you will get your answer will be 1.929 radian. Okay, that is the first one. And then the second one, 320 degree. So 320 degree equal to 320 degree multiply with pi over 180 degree. And then, okay, this one for B, it doesn't state it to you to make it the radian in terms of pi, right? So you need to substitute the value of pi, which is given here, 3.142. You need to substitute the pi into this value. Okay, and then 320 degree multiply with 3.142 divide by 180 degree. Then you will get your answer is 5.586 radian. Okay, that's it. That is how you do it. Okay, let's remember. Let's recall back. Okay, in order for you to convert, okay, we know that 180 degree is equal to pi radian. Okay, from here, okay, if the question asks you to convert from radian to degree, okay, from radian to degree, so it means that 1 radian is equal to this one. 1 radian pi, you bring to the right, so 180 degree over pi. Okay, this one, if you want to convert from radian to degree, and then if you want to convert from degree to radian, so the basic one is you look at this one. Okay, we want to from degree, this one degree, right? So we want to make, so 1 degree. Okay, this one divide by 180. This one also divide by 180. So we get pi over 180 degree radian. Okay, so you just need to remember this one and this one. Okay, both of this formula come from this formula, this one, which is 180 degree equal to pi radian. Okay. Okay, class. Before we proceed with our next subtopic, which is subtopic 1.2, let's look at this one. Okay, why before this you learn angle was in unit degree, right? But in maths, you learn that angle can also be in unit radian. Okay, radian. Okay, radian. Radian. The symbol, the symbol is one rad. If you one red, if you look at this one red after this, so this one represent radian. Okay, one radian or one radian. Okay, this one radian. Okay, if you look at the terms red and this one red, so it means that it represent the radian. Okay, so why you need to learn the angle. Before this, you just know that the angle was in unit degree, but then in admits you learn that angle can also be in unit radian, which is the new unit. Why? Because look at this one. In circular measure, the normal unit used to measure angle is in degree. Okay, before this is the basic knowledge you learn in maths. Okay, however, in some mathematical disciplines, circular measures in degree are less suitable. Okay, based on the mathematical discipline, circular measure in degree are less suitable. So that's why a new unit called the radian is introduced to measure the size of an angle. Okay, if you want to know further information regarding to why we use the unit radian instead of degree, you just need to type in YouTube. So why? Okay, find out on your own. Okay, this one because okay, in some mathematical disciplines circular measure in degree are less suitable, so that's why some scientists discover a new unit called the radian to introduce the measure of the size of angle. So because radian is more suitable than degree in measuring the circular measure. Okay, what I just show you just now, which is if the length of arc AB is equal to R, so the angle which is in the forms of unit radian is equal to 1 radian. And if the arc length AB is equal to 2R, then the radian will become and the angle will equal to 2 radian. If the arc length AB is equal to 3R, and then the angle is equal to 3 radian. So what happens if the arc length AB is equal to pi r? So we know that based on the first, second, and third, we know that the angle is equal to pi radian. Okay, this one is equal to pi radian. So let's look at the fifth one. Let's look at the fourth one, which is we know that this one. Assalamualaikum and salam sejahtera. The third one, times of if the length of 2r, and then what happened to the radian, which is the angle. So the angle is equal to 2 radian. Okay, 2 radian. Let's look at this one. Look at this one. This is equal, right? So 2 times of if the length of arc AB is equal to 2 times of radius, then our angle, which is in the unit of radian, it will equal to 2 radian. Okay, so let's look at the third one. If the length of arc AB is 3 times the radius, so 3 times the radius, 3 times the radius, we still fix the value of radius, which is 2, and then the length of arc is 4. But this one, the third one, they said that if the arc length AB is equal to 3 times radius, so 3 times radius means 3 times 2, 6. So we need to make this length of arc into 6, and then look at what happened to the angle. Okay, you need to drag the value of A. Okay, look at this one. Okay, length of arc is 6, and then look at the angle, which is in the unit of radian. So the angle is equal to 3 radian. So we know that this one is 3 radian. We got 3 radians. So what happened if the Okay, class. Let's look at our next subtopic, which is subtopic 1.2, arc length of a circle. Okay, look at this one. The diagram on the right shows a little girl on a swing. The swing sweeps through 1.7 radians and make an arc of a circle. So what is the arc length made by the little girl on that swing? Okay, this one. This is length of arc. So in this subtopic, we are going to learn how to get the length of arc by the angle in unit radian. Okay. So what formula can we use to solve this problem? So in this subtopic, we are going to discover a new formula to find the arc length of a circle. Okay. So this is our learning objective, which is to determine the arc length, radius, and the angle subtended by the subtended at the center of a circle. Okay, let's look at this one. Okay, I think this is the very familiar formula you learned before this in maths. Okay, let's look at this one. This is the minor arc length. Okay, in order for you to, before this, in maths, you already learned that in order for you to find the minor arc length of AB, so the formula is minor arc length AB over with angle AOB, this angle, equal to the circumference. So the formula of circumference is 2 pi r over 360 degree. Okay, so we want to find minor arc length AB over with angle AOB. So angle AOB is equal to pi. Okay, this one pi equal to 2 pi r over 360 degree. So in order for us to find the arc length AB, the pi here you need to bring to the right side, so it will become multiply with theta. So minor arc length AB is equal to 2 pi r over 360 degree multiply with theta. Okay, this is the basic formula that you learn in maths. Okay, where theta is the angle in degrees subtended at the center of the circle, or whose radius is r unit. Okay, this is the basic one you learn in maths. Okay, now let's look at maths version. Okay, wait. Okay, look at this one. Okay, look at this one. Okay, in maths. Okay, however, in angle AOB, which is this one, AOB, is measured in radian. So when angle was in the unit of radian, so the formula is just the same. The formula is just the same. This one. Okay, minor arc length AB is equal to theta equal to circumference over 2 pi. Okay, why 2 pi? Okay, remember pi is equal to 180. Okay, if 2 pi, then 200 2 times 180, so it will become 360 degree. Okay, this one in unit radian. Okay, this one in unit radian. So that's why the angle in degree, right? But this in this chapter you are going to learn angle in the unit of radian. So 360 degree, you need to change into radian lah. So if you want to change into radian, 360 is equal to 2 pi. Okay, the circumference later. Okay, this one, minor arc length AB. So minor arc length AB we represent as the S. Okay, after this, if you look at the symbol of S, so it means that it is represent the arc length of the angle. The arc length is equal, okay, as we change it into the symbol of S over with theta. Okay, theta, which is this one, equal to circumference. So the formula of circumference is 2 pi r over with 2 pi. 2 pi y, this one 360, right? In degree. But in this chapter, you are not using degree. You are going to use angle in unit radian. So you need to change 360 degree into radian form. So this one, 360 degree is equal to 2 pi. So this one 2 pi. And then after that, okay, let's look at this one. Okay, this one we can cross. Okay, this one, sorry, this one pi we can cross. This one also we can cross. Okay, and then this one already we eliminate this one. we eliminate this one also. And then pi, bring it to the right, it will become multiply pi. So this one remaining is the unknown r. So we know that s is equal to r theta. S is the length of arc equal to radius theta. Okay, remember this one. Theta, this one, it must be in unit of radian. Okay, it must be in unit of radian. It is no longer in unit of degree. So make sure theta is in unit radian for this formula. So we know that in order for us to find the arc length of this one, length of arc AB, which represent the unknown S, so we know that the formula is S is equal to R theta. So this is the formula for you to find the length of arc AB. Okay, S, which length of arc, equal to R means radius, theta is the angle which is in unit radian. Okay, remember this one must be in unit radian. Okay, class. Let's look at example 3. Okay, find the arc length S for each of the following sectors P O Q with center O. Okay, use pi is equal to 3.142. So let's look at A. This is the given here. Okay, we want to find the S, which is the length of arc PQ, okay, which represent the variable S. Okay, length of arc length S is equal to R theta. So S is equal to 5. 5 is the radius, which is 5. Multiply with theta 0.9 radian. So 0.9. Okay, this one already in the unit of radian. So that's it. You just need to take out and put it in the formula, which is 0.9. So 5 times 0.9 is equal to 4.5 centimeter. That's it. This is how you get the value of arc length. Okay, this one done already for A. Now look at B. Okay, look at B. S is equal to R theta. Okay, let's look at R. R, the value of radius is 6 centimeter. Multiply with theta. Theta, what is the value of theta? 2 over 3 pi radian. So 2 over 3 pi radian. So 2 over 3 pi radian. Okay, now you just need to simplify one. Wait, this one. Just cross 1332. So 2 times 2, 4 pi. This one 4 pi. After you got 4 pi, so pi, it's already stated to you. Pi, use the equal to 3.142. So 4 in bracket 3.142. And then put it in your calculator, then you will get the answer is 12.57 centimeter. Okay, let's look at C. Okay, for A and B, there is no problem because the data was already in the forms of unit radian. Okay, let's look at C. Okay, if you look at C, this one is 140 degree, isn't it? Okay, the question asks you to find the length of arc of the following sector POQ. POQ. So the length of arc that you need to find is this one, not this one. Okay, this one. If you want to find this length of arc, okay, this is the angle given here, and you need, this is not the angle of this one, of the length of arc S. You need to find this angle. So in order for you to find this angle, you need to do it 360 degree minus with 140. So your answer will be 220 degree. So this one is 220 degree. Okay, this one, it is in the forms of unit degree. Okay, remember the formula for this chapter, S is equal to R theta. Theta must be in unit radian. So what should you do? You need to change the unit, the angle of 220 degree into radian. So how? Okay, let's look at this one. This one is 220 degree. We done already to find this angle. So 220 degree multiply with, okay, this one from degree to radian. You want to convert from degree to radian. You need to multiply with pi over 180 degree. So this one lah. So pi times with pi over 180 degree. So this one, the value of pi is 3.1 3.142. So you need to substitute 3.142 over 180 degree and then key in your calculator, then you will got your answer is 3.84 radian. Okay, you done already to find the value of theta. Now, actually we want to find the value of s, right? So we already got the value of theta, then you just key in the formula. S is equal to r theta. So what is the the value of the radius? So the value of the radius is 10 centimeter. Okay, 10 multiply with the radian we already calculate just now, which is 3.84. So 3.84 multiply, and then you will got your answer is 38.4 centimeter. That's it. This is how you do it. Okay. Okay, class. Let's look at example 4. Okay, for example 4. Wait. Okay, look at example 4. This one. For example 4, the diagram on the right shows a part of a circle with a center O and a radius of RCM. This one RCM. And then given that angle AOB is equal to 1.3 radian and the arc length AB and the BC are 2.6 centimeter and 1.4 centimeter respectively. So calculate this one. AB is 2.6 centimeter and then BC is 1.4 centimeter. So look at A, which is calculate the value of R. Calculate the value of R. So where is R? R is the radian. So the question asks you to find the value of R. So this one, angle, it's already given to you, and the S is also given to you, which is 2.6. So now you just need to use the formula S is equal to R theta. So S is equal to 2.6, and then S is equal to 2.6. Okay, if just look at this one, S is equal to r theta. So we want to find the value of the radius. So this length of arc already given to you, which is 2.6. 2.6 is equal to radius. We don't know the value. R is the value that we want to find, and then theta, which is 1.3. Okay, 1.3. Okay, now we want to find the radius. So R is equal to 1.3. Bring it to the left, then you will get your answer is 2.6 over 1.3. Then you will get your answer is 2 centimeter. So we know that the value of radius is 2 centimeter. Okay, now we done already for A, which is to find the value of radius. Now let's look at B, which is to calculate the angle BOC. BOC, this is the angle that we want to find, theta, in radian. Okay, remember this one in radian. So for B, we know that S, which is the length of arc, BC is 1.4, and then radius we just calculate just now, which is 2 centimeter. And now apply this formula, which is R. S is equal to R theta. So S is equal to R theta. Okay, the value of S is 1.4, we know already, and then radius is 2 centimeter. Okay, and then theta, we don't know the value of theta. So, and then theta is equal to 1.4. To bring it to the left, then you will get divide by 2. So, we know that theta is equal to 0.7 radian. Okay, that's it. This is your answer. This is very easy. As long as you know the formula, and then make sure theta it is in the unit of radian. If it is in unit of degree, then you need to convert into radian. Okay. Okay, class. Let's look at our next learning objective, which is to determine the perimeter of segment of a circle. Okay, let's look at example 5. Okay, the diagram on the right shows a circle, this one, with a center O and a radius of 10 centimeter. Okay, the chord AB subtend an angle of 114 degree. Okay, the chord AB, where is chord AB? A, B. The chord AB subtend an angle of 114 degree at the center of the circle. So calculate the perimeter of the shaded segment ABC. This one, the green shaded region. This is the thing that we need to calculate, which is the perimeter of the shaded segment ABC. Okay. So let's look at the first thing. Okay, what is the first thing that we need to do? Okay, this one, theta, it's already given, but it is in the unit of degree. Radius already given to you. No. Okay, we just you need to find the this one, length of arc of ABC. The length of arc ABC that represent the variable S, right? Okay, so S. Okay, this one. We need to find the length of arc. S is equal to R theta. Okay, now this one. This one is 114 degree. This is in the forms of degree. So you need to convert into radian. Okay, how you want to convert into radian? Okay, 114 degree is equal to 114 multiply with, okay, from degree to radian. Okay, remember this one. 180 degree is equal to pi radian. Okay, so we want to convert from degree to radian. Okay, from degree to radian. So 1 degree is equal to pi over 180 radian. So pi over 180 multiply with pi over 180 degree radian. So what is your answer? Okay, pi you need to substitute with this value at 3.142. Okay, and then you will get your answer is 114 multiplied with 3.142 over 180 degree radian. So your answer will be 1.990 radian. Okay, that's it. So we already know the value of theta, which is 1.990 radian. Okay, and then we can find the length of arc ABC, which is S is equal to radius is 10 centimeter multiply with theta. Theta, we already get the value of theta, which is 1.990. So your answer will be 19.90 centimeter. That's it. So we already know the length of arc ABC, which is this one, which is 1990 centimeter. Okay, now how to find the length of AC? This one. How to find the length of AC? So in order for you to find the length of chord AC, this one chord. This one is chord AC. You need to apply the cosine rule. Okay, remember the cosine rule? You already learned this formula before this. Okay, so you need to apply this cosine rule in order for you to find the length of chord AC. Okay. So what is the formula? So this is the formula. A square equal to B square plus C square minus 2BC cos A. Okay, let's this one is A, this one is B, this one is C. Okay, so A square, we don't know the value of A square, right? This is A need, the unknown A is the thing that we need to calculate, which is the chord AC, the length of chord AC. So this one A square equal to B square. B square is, this is the radius B. So radius is 10 centimeter. So 10 square plus with C square. C square also 10 centimeter. 10 square minus with 2BC. 2BC. So BC, the value of BC is 10, 10. 10 multiplied with 10. And then cos A. Cos A. A is represent the theta. So A is, the theta is, what is it? The theta is 114. 114 degree. Okay. And then after that, okay, we want to find the value of A, right? Okay, you need to square root both sides. This one, you need to square root both sides. Okay, you need to square root both sides. So this one eliminate, so it will become E. And this one, okay, key in your calculator and then you will get your answer is 16.77 centimeter. Okay, after that, okay, look at the question ask you. The question asks you to calculate the perimeter of the shaded segment. Shaded segment. So this part lah, length of arc ABC and the chord AC. So we know that length of arc ABC is 19.90 centimeter. So perimeter, perimeter ABC shaded is equal to the length of arc ABC is 19.90 centimeter. Okay class, let's look at this one. The question asks you to calculate the perimeter of the shaded segment ABC. So perimeter ABC of the shaded one is equal to 19.90 cm plus with, okay, the chord AC, the value that we just calculate, which is this one A, not 9, 16.77. So 16.77 centimeter. So your final answer is 36.67 centimeter. So this is the final answer. Okay. Wait. Okay class, let's continue our next and final learning objective, which is problem solving involving arc length. Okay, let's look at this one. Okay, with the knowledge and skill on converting angle from degree to radian and vice versa, as well as the arc length formula, S is equal to R theta and other suitable rule, we can solve many problems in our daily life involving the arc length of a circle. Okay, let's look at example 6. Okay, the diagram on the right shows the regions of the shot put event drawn on a school field. The region is made up of two sectors from two circles, which is AOB, okay, AOB, and then POQ, both with center O. Given that angle AOB equal to angle POQ is equal to 50 degree. Okay, this one is 50 degree. This one, let's, okay. This one, this angle is equal to 50 degree. OA is equal to 2 meter. So OA is the value of radius for this small circle here. Okay, which is 2 meter. And AP is 8 meter. And then calculate so if AP is 8 meter, so the radius for POQ is 8 plus 2, which is 10. Okay, calculate the perimeter of the colored regions ABQP. ABQP. So the purple, the pink one, you need to calculate the perimeter of the colored regions ABQP in meter. Okay, what should you do? Okay, let's look at the first one. Okay, you need to understand the problem first. Okay, the short put region consists of two sectors, AOB and POQ from two circles, both with center O. The sector AOB has a radius. Okay, look at this one. The sector AOB, the radius is 2 meter. Okay, and then AP, 8 meter. And angle AOB, and POQ, the angle is just the same, which is 50 degree. Okay, now we know this one is 50 degree. Okay, and then look, the second step, you need to planning the strategy. So the first thing that you need to do, as usual in this topic, the very important thing is for you to convert from degree to radian. So you need to convert 50 degree into radian and use the formula of S is equal to R theta to find the arc length AB and PQ. To find the arc length AB and PQ. Okay, the perimeter of the shaded region ABQP can be obtained by adding all the sides and enclosing it. Okay, now let's calculate. Okay, wait. Okay, let's look at this one. implementing the strategy. Okay, this one we need to start to calculate. Okay, look at this one. Okay, this is the information that you need to know lah. 180 degree is equal to pi radian. Okay, so 50 degree. So the first thing you need to do is to convert 50 degree into radian. So 50 degree is equal to 50 degree multiply with pi over 180. So pi here you need to convert into the value of pi lah, which is 3.142. And then you will get your answer is 0.873 radian. And then after you got the angle, so we know that the angle of sector AOB and POQ is just the same, which is 50 degree equal to 0.873 radian. Okay, so let's find the length of arc AB first. Okay, the length of arc AB is S is equal to R theta. So S is equal to, the radius is 2 meter. So 2 multiply with theta is in the forms of unit radian, which is 0.873, and then you multiply, then you will get your answer is 1.746 meter. So for the length of arc AB, we already know that the value is 1.746 meter. Okay, we done already to find the length of arc AB. Now find the length of arc PQ. Okay, length of arc PQ, S is equal to R theta. We use still the same formula. S is equal to the value of our radius. Radius of sector POQ is not 8. 8 is just from A to P. So the radius of sector POQ is 8 plus 2. So we got 10. The radius of sector POQ is 10 meter. Then multiply with the theta, which is 0.873, and then you multiply, then you will get your answer is 8.73. 8.73. So this one is the length of arc PQ, which is 8.73. Okay, after that, the question asks you to calculate the perimeter of the colored region AB, QP. So the pink one here, the regions of the pink color. Okay, so the arc length AB, the arc length to find the perimeter of this ABQP is the length of arc AB plus with this one and plus with the length of arc PQ and plus with this one. Okay, the length of arc AB is equal to 1.746. This one, 1.746 plus with 8. 8 is here. This one, 8 is in here, and then the length of arc PQ, we just already get the value, which is 8.73. 8.73, and then plus with this one, PA. PA is 8 meter, and then you sum up this value, and your final answer will be 26.48 meter. That's it. That is how you do it. Okay. In this chapter, the very important thing is you need to convert from degree to radian, because this one. Okay, because this one, okay, S is equal to R theta. Theta must be in unit radian. Okay, and then what else? If you want to convert from radian to degree, okay, from radian to degree, so you need to remember this one, which is pi radian is equal to 180 degree. So if you want to convert from radian to degree, so 1 radian is equal to 180 over pi. So this one is in degree. And then in order for you to convert from degree to radian, okay, from degree to radian, so from this one, okay, 1 degree is equal to pi over 180. This one from degree to radian. So remember this one. This is the 3 formula that you need to remember in this subtopic 1.1 and 1.2. So that's it. So this is our last learning objective for this video, and I hope you can understand. So that's all. Thank you.